So we want to find the volume of the solid of revolution formed by revolving the region bounded above this graph and below by the x-axis over the interval from 0 to 4. But this time it's not around the x-axis or y-axis, it's around y equal to -2. So let's draw a picture of this situation. Okay. So if I were to ask you what kind of an object this guy is, I hope you would all tell me that that's a line, right? That's a line, a slope is -1. So I can draw a line like this. The slope is -1, and that makes this point over here 4 as well. Because 4 minus 4 is equal to 0. And this curve is y is equal to 4 minus x. Okay. It's bounded below by the x-axis. So I want to draw it in this time. So I'm going to draw it slightly above like this. And this is y is equal to 0. That's the x-axis. Okay. And then they say we're going from 0 to 4. So I have this 0 to 4 here or here. But this part's important. They say we're going about the line y equal to -2. So if I took the y value of -2, that's about here. And let me put this in red. This guy looks something like that. This. Is there any questions about this so far? No questions. Okay. So my question for you guys is this a washer or a disc? Disc or washer? What do you guys think? Anybody have any feeling? Is anyone still here? Disc or washer? Ken says washer. Someone messages probably said disc. Someone else says washer. 2 votes for washer, 1 vote for disc. Okay. I feel like this should be a washer. And the reason why is because it says it's bounded from above by this guy and below by this x-axis. We're going around the line x equal to -2. So when we revolve this triangle around, you're going to have this giant hole in the middle here. So actually, this one's going to be a washer. And I think the first thing we should do is we should chop up perpendicular to the axis of rotation. So for us, we're chopping up like this. We do not go all the way down like this. Why? Because it says it's bounded from below by the x-axis. So this region can't drop below the x-axis. So the picture definitely looks like that. Does that make sense? Terry, can you see how this is a washer and not a disc? Because there's going to be a giant hole here. Okay, perfect. Good. If I were to draw a picture that represented this scenario, let's say I took this piece right here. If I draw it off to the side, it's like you have one point there, and then it's like the distance from here to here, and it has to be the same below. So maybe that bottom point's like here. And this is the washer part, that's the hole. And then this part here is the r big, and then you have this little bit of thickness here like this. So in this case, you got to ask yourself, is it going to be a dx or a dy? What do you guys think, dx or dy? Or what do you all think? I got 1 vote for dx, 2 votes for dx, 3 votes for dx. You got to see that this little bit of thickness lies on the x-axis. So I think it's dx. So let's set up our integral. It's going to be an integral. It's going to be the dx thing. What's the smallest x could be? According to my picture, the smallest x could be is 0. What's the biggest that x could be? The biggest that x could be is 4. You can tell from our picture, but they also gave us the bounds region of integration right here. Okay. So what I need you guys to see is I need you guys to figure out what the R big and R small are. So if we go from here, the middle, say this is the middle. If we go from here to here, that's going to be R big. And if we go, hold on, let me move this. If we go from here to here, that's going to be R small. What do you guys think R small should be? Anybody have a thought as to what R small should be? I'll give you a hint. R small is the distance from here to here. What do you think that distance is? I have 1 vote for -2. Do we have another answer? I have 1 vote for 2. So we have 1 vote for 2, 1 vote for -2. Any others? Well, the distance from here to here is 2. I know this is the y value of -2. We're talking about distance. We're talking about length. So R small is equal to 2. What about R big? What do you think R big is equal to? Any guesses? I'll give you a hint. It's not 4 minus x. 4, if it was 4, then your line would be right here because the distance from there to 2 is 4. So if it's a constant, it'd be like a circular cylinder, but it's not that. It's this downward sloping thing. We have another vote for a constant. If it was 6, again, this would be a horizontal line, and this whole distance here would be 6. This line is not a horizontal line. This line is a downward sloping line. So we're definitely going to need to use this. It involves 4 minus x. But the distance from 4 minus x is just from here to here. I want to go from here all the way down to here. So what do I need to do to this to go all the way down? It's going to be 4 minus x plus 2. Oh, no, it involves this. It definitely involves this 4 minus x. So does that make sense? So the height is here plus 2 more. Yeah. So this is going to be pi r big squared minus pi r small squared like this. And that's going to be equal to the integral from 0 to 4 pi times 4 minus x plus 2 squared minus r times 2 squared dx. Does that make sense? Once you have this, you can just multiply it out and integrate. We have 8 minutes left.